In this video, we will start with the remainder theorem. You will find this on page 381 in the Namibian AS-Level Mathematics textbook, y equals mx+c to success. The remainder theorem. In the previous sections, we learned how to use long division to find the remainder when a polynomial is divided by another polynomial. We will now learn another method to find the remainder when a polynomial is divided by a linear divisor without going through the process of long division, basically just to find the remainder. So in example 15, we did the following long division and we got this answer. This was the quotient, this was the divisor, this was the remainder. Now, if we make the divisor equal to 0 and we substitute just the -4 in, there we do it. We get -124. So we can find the remainder without doing any division. Okay, so px, we just substitute it in and then we get the remainder. Now let's look at the general. So in general, if a polynomial px is divided by a divisor dx equals x minus c to give the quotient qx and the remainder r, then px, x, okay, so that's the statement that we did in previous videos also. It's the divisor, it's the quotient plus the remainder. If we make the divisor equal to 0, okay, and we substitute in that place of x, c, then what happens? This falls away and we are just left with the remainder. And that's what's basically happening there. So the remainder theorem. If a polynomial px is divided by x minus c, the remainder is pc. So we can just substitute that. If a polynomial px is divided by ax minus, the remainder is b over a. Because remember, can I show you? If you have ax minus b equals 0, then you have ax is equal to b, divide a, and that is basically then that b over a. Let's look at an example. It's actually very easy. Okay, so let's look at example 17. Use the remainder theorem to find the remainder when this is divided by x minus 1. So basically, I'm just going to put in the place of this fx, I'm just going to put 1 and the answer is going to be -12. Okay, so before I'm going to let you stop the video and I'm going to let you do at least 2, so A and C, I'm just going to take you back to the previous example. So if I'm asking you and I want to get to this -12, I'm just going to clean here. I could have also do it just like this. So what was fx? Fx was equal to, and let's just see which one I gave you there. Okay, so it was equal to 3x to the power 3 plus 4x minus 5. Okay, so basically, if I'm going to divide it by x plus 1. Oh, it's this one here. Okay, so x plus 1. And now I'm just going to say, okay, so if it's x plus 1, I put it equals 0, so x is equal to -1. So if -1, and then I would have just say -1, 3, plus 4, -1, minus 5, and that would have given me, this is negative, so it's -3, minus 4, minus 5, and that would have given me that -12 that I got there. Okay, so let's just go back to the next one. Okay, so basically that one was just the same answer, but the polynomial was different. Okay, so let's start with try now 17, number A. So fx is equal to 2x3 minus 3x squared plus 2x plus 1. And now I'm going to, it's x minus 3, so if it's x minus 3, I put that equals 0, so x is equal to 3. So I'm going to say f3, okay, And then I'm just going to substitute it in there. So it's 2, 3 to the power of 3 minus 3, 3 squared plus 2, 3 plus 1. So this is going to be 3 times, so this is going to be 27 times 2, so it's 54. This is 9, so it's negative 27 plus 6 plus 1. And the final answer is 34. And then I'm going to do also number C. So fx x4 minus 2x squared plus 3x minus 1. Now I'm going to say x plus 2 so x is negative 2. So if negative 2 equals negative 2 to the power of 4 minus 2, negative 2 squared plus 3, negative 2 minus 1. So this is going to be 16, right? This is going to be 4, so it's negative 8, so it's negative 6. Okay, so basically I'm just going to finish off this and simplify, and I will get an answer of 1. Okay, so it's 8 minus 6, so it's negative 2. This is 8 minus 6, it's 2 minus 1, and the final answer will just give me a remainder. So every time this answer is just the remainder. I'm not able to find the quotient, but I'm able to find the remainder.